This is the second part of the unit on soil manipulation and its consequences. We will concentrate on this unit on soil compaction. Compaction is a common soil problem resulting from the repeated application of surface pressure to soils. Its effect on soil structure is almost always detrimental, causing loosely associated aggregates to coalesce into more massive structures with far less pore space. In other words, soil compaction increases soil bulk density. Because pore space is limited, compacted soils drain poorly and are poorly aerated. Root penetration is also impeded, limiting the volume of soil that plants access for water and nutrient supplies. Ultimately, soil compaction can seriously decrease plant performance and may even prevent plant growth in some cases. Soil compaction can occur at the soil surface, we call this crusting, in the cultivation zone, called surface compaction, just below the cultivation zone, called plow pan, or in the subsoil, called deep compaction. Major causes of soil compaction are both natural and man-made, and include rain, irrigation water, wheel or foot traffic, tillage, and continuous cropping. Hard rains or irrigation water hitting bare soil can squeeze out, so to speak, pores and small open cavities. In crop agriculture and in some turf management situations, a major cause of compaction is the repeated travel of heavy equipment such as a tractor over the soil surface. The extent of compaction, whether in the cultivation zone or in deeper soil layers, is proportional to the force, frequency, and duration of pressure applied. These factors are not only dependent on the size of vehicle, infiltration, pressures, and width of tires, but also on the characteristics of the soil. In general terms, the ability of a soil to withstand compression decreases as the soil increases in water content and becomes more plastic, and when the soil becomes more cohesive due to the predominance of clay. Hence, wet clay soil has much lower strength than dry sandy soil. The net effect of compaction is to increase the bulk density of the soil, in this example, from 1.25 to 1.46, as heavier equipment is used to consequently decrease the macropore space, in this case, by over 10%. The type of tillage system used also affects the severity and location of compaction. In the example illustrated here, disc tilling, the orange mustard-colored line, used continuously for 10 years without alternative tilling methods, causes more compaction than chisel, the blue line, or moldboard, the black line. In other systems and situations, compaction can occur from non-vehicular traffic. For example, if it is applied often enough, even the force of the human footstep can have devastating results in a landscape or turf setting. However, soil compaction is not restricted to human activities. It occurs in natural areas, as shown here by deer paths. Cattle grazing on fields can also cause soil compaction that requires proper management. Soils can also suffer significant compaction as a result of plowing, tilling, or working with them when they are wet. Heavier soils are particularly prone to this problem, as the soils often remain wetter in the spring when it is desirable to prepare seed beds for early planting. From an agronomic perspective, a single incident of subsoil compaction can affect crop performance for several years, especially when combined with other environmental stresses such as drought or waterlogging. This graph illustrates how a compaction event in 1982 showed some recovery at first, but on subsequent stressful years of either drought or excessive moisture, yields were below the average achieved in uncompacted soil. Continuous cropping with a single species can prolong the effect of subsurface compaction, whereas crop rotation can alleviate it if the crops have different depths of rooting. Compaction is a particularly important issue to address in landscapes that are used repeatedly, such as sports fields, including those for soccer and football, and golf courses. Even a well-tilled, crumbly, structured soil can suffer from surface compaction caused by rain or irrigation water. This forms a crust of varying thickness that limits water percolation, impedes gas exchange, and interferes with seedling emergence. In some soils, repeated cultivation with heavier cultivation equipment can also result in the formation of a plow pan or hard pan, which is a relatively thin horizontal compaction zone just below the zone of cultivated soil. Such layers, which often contain large amounts of unstructured clay, can impede water percolation, root growth, and plant performance, depending on the thickness and degree of compaction. So, to take a hint from a well-known television personality, let's consider the top 10 reasons to avoid soil compaction. It causes nutrient deficiencies, reduces crop productivity, restricts root development, reduces soil aeration, decreases soil available water, reduces infiltration rate, increases bulk density, increases sediment and nutrient losses, increases surface runoff, and damages soil structure. We have seen that the cultivation of soils may lead to problems with compaction and erosion. However, by employing proper soil management practices, the potential for these problems can be reduced. Best practices to alleviate compaction generally involve limiting the extent and duration of force applied to the soil, or amending or treating the soil so as to maintain soil structure. In most crop ecosystems, cultivation is a possible method of reducing soil compaction. However, it is not possible with turf unless it is time to reseed. The effects of compaction can be relieved to some extent by core aeration. As we saw earlier, healthy soil gives us clean air and water, bountiful crops and forests, productive rangeland, diverse wildlife, and beautiful landscapes. Proper management practices that minimize compaction will permit soils to remain healthy and productive.